This has been a wonderful symposium. I'd like to say thank you especially to all of those who helped out, the CERIAS staff, in particular Randy Bond, Joel Rasmus, Joe Maslin, Lori Floyd, Marlene Bells, Marlene Walls, Ed Finkler, Ed Cates, Adam Hammond. All have just done a tremendous job for us. One final announcement regarding the symposium. We have a poster contest every year where we have a panel of distinguished judges who go through and look at the posters for originality, for presentation, and in talking with the students, your ability to understand what it is you have on your poster. It's not a given necessarily. But there are some recognitions for these. The number 3 poster was the poster on printer security and forensics by Michelini, Kana, and Dell. And you will be receiving a certificate of acknowledgement for that. The number 2 poster, optimal finger combinations and multi-finger biometric systems, Marvin Michaels, Shimon Modi, and Stephen Elliott. And for the student involved, there's a $100 certificate prize along with a certificate for that poster. So congratulations on that. And the number 1 poster, as judged by our panel, automatic reverse engineering of data structures from binary execution. And this was Lin, Zhang, and Zhu. And the student involved here gets a $250 prize and a recognition certificate. So congratulations to all of the students who participated. So in selecting a speaker for today's seminar, we had some fortuitous circumstances, but also some direction. And part of the direction was who could provide an interesting and deep technical perspective on the field. Information security is a young field in some respects, but does have some rich history. And as I've said in several meetings and classes, there's a lot that occurred before Google came along. And if you can't find it in Google, you may not think it exists, but it does. And there were some people who were laying the groundwork for that. Our speaker today is Dr. David Bell, who has had a long career in the field. He's one of the few who's had his name immortalized of sorts in one of the things that we all learn along the way, the Bell-LaPaglia model for information flow and assisting to maintain confidentiality. But he has actually had an influence in a number of other areas, including development of some of the documents in the Rainbow series and the Common Criteria, development of secure systems and testing, and a number of other things. I'm not sure how many of which he can talk about, but are not going to be necessarily the topic of his talk today. Dr. Bell got his PhD at Vanderbilt University, and then went on to a career that included 3 separate instances of working at MITRE, place just couldn't seem to get away from. And in between, he spent time at some government agencies, startups, and an independent consulting firm. Turns out we have a number of mutual friends who were on that. We were just talking about it. He has since retired, in the sense only that he doesn't go to work every day at a place that has deadlines and requirements, but he continues to be very involved in security and writing, in speaking before groups, and in thinking about some of the hard problems. We're very fortunate to have him here today to share with us some of his thoughts on security, and in particular, how everything he needs to know about security he learned in 1974. So please join me in welcoming Dr. Bell.
Jane, is this on?
It should be, yes.
Oh, okay.
It's just for the camera.
Oh, it's for the camera. Okay. Good afternoon. Should have gotten. So, This is a talk that I first gave last May. A friend of mine, Blaine Burnham, got me to go out to Omaha, and I wasn't sure what to. He bribed me by promising to have my talk the same weekend as Berkshire Hathaway's stockholders meeting, which I'd wanted to go to for years. So I wasn't sure exactly what I wanted to talk about, and this Robert Fulghum essay poem thing, everything I needed to know I learned in kindergarten. And it kind of stuck in my head, and I couldn't get rid of it, so that I ended up sort of structuring my talk around this. I've given it several other times with only minor modifications. For all of you who are currently connected and really want to go look at this, if you point yourself at offthisweek.com/talks, there's a list of talks, and the first one there is CERIAS 2010. That's actually what I'm driving here. The reason I say that is that on the last page, my parody of Fulghum is available. It was up here just a second ago. Now, the first thing you might think when you see a title like that is, what in the world can he be talking about? Look at everything that has changed. The speed of things, the speed of our computers, our cycles have changed. We went from big iron to little tiny computers. And the diagram in the top right is an actual map of all of ARPANET in 1974. You could count them. The picture at the bottom is the internet as mapped in 2005. I tried to find an update, but I was unsuccessful. So what I really mean is not that things have not changed, but that the principles underlying the whole issue of security have been remarkably constant. Now, there's another footnote, which is when I say I learned it, I mean somebody in the community learned it by /74, and eventually I found out. A number of these things were available in 1974, but I had not taken the time or had the opportunity to go look at it. During the time from 1974 till I retired the second time in 2005, there was only one fundamentally new thing, my opinion, that came up. Everything else was old wine, new bottles. So here's my career. Most times people think of me as a person who just did modeling all of his life. There's a whole career. That big dip there near the end, that's the first time I retired, 2000. After the attacks, I unretired and worked for 3 years. So that's the career. You'll notice that I spent most of my time doing security, but the little red thing, there was a bunch of modeling early on, and then it tailed off, hardly any. I mean, every once in a while someone would say, you know, we need modeling work, and we'd look at the toolkit and decide, no, what we've got's not quite right, so you need to go off and do something. So my view of the important principles of security came from that early modeling work, but it informed my entire career. The things I had to learn to do the modeling, the things that Len and I did together were the basis for most of my career. Now, on the other hand, see the little red dot? At that point, that was 1983, I had spent 8 years not doing any security at all. And at that point, security was a minor part of my career. Well, at that point, as I mentioned one time jokingly in a description to be used in an introduction, I was seduced back into the field by Roger Shell and Marv Schaefer. Much to my chagrin, they printed it in the proceedings. And I went off to work at the Computer Security Center. So, though everybody thinks of me as a modeler, I think of myself as a security dude. Now, when I came into the security field, which was '71, I looked at the field and I had the same reaction I had for a number of other fields. All the good stuff has already been done. I will never catch up. Now the things that had been done by this time, one of those three I actually knew something about. The Ware report and the Anderson report, I only became aware of their implications later. But I did read some of the Multics papers from 1965 where they're trying to build big iron and do protection. And many of those papers are the classics. I don't know if you can find them on Google, but if you can't, you should get a piece of paper that has them written down. They're extremely important. Reading about how protection in safe deposit boxes with diamonds will help you avoid the mistake of believing you can protect things smaller than the container you've got them in. I'm not going to talk much about the Multics papers. That was actually the best kind of stuff that was out there that talked about security in an abstract kind of way, but it was tied to a particular operating system, the Multics operating system. The other two things I will talk a bit about, the Ware report was published April 1970. The Glazer Panel that was put together by the Air Force, who was executive agent for computer security for the Department of Defense. Their job was to figure out computer security for all of DoD. The Glazer Panel was put together to try to put together a plan of action for computer security. And one of the driving forces behind wanting to do that was that computers are expensive. Really expensive. I did a retrospective some years ago where I actually dug up the information, and I pointed out that in those days, your standard computer, the IBM 360, and I'll get the following letters wrong, and I compared it, how much memory it had, how much storage it had, and then I pointed out that that computer cost $30,000. That's the rental cost every month. They're so expensive that the military services wanted to be able to buy one big computer and do the weather over here and the intelligence summary over there, but they were concerned that some of the intelligence might end up in the weather summary. So they put together the panel to do a number of things. One, to see if they could use commercial systems as they existed, and the other to make a plan about what to do. The most significant chunk of the Ware report, to me, was this diagram, which shows network vulnerabilities as of 1970. Now, I'm sure this is hard to read for you, but you've got radiation, you have taps, you have improper connections, you have access control, you have replacing the supervisor, you have, where did those go? There were recorders on remote consoles. In the large sense, if you abstract from the pure technology that they're talking about, that's a pretty good description of what people can do to you that's evil on the network. Now, one of the interesting things to me, we had a bit of a conversation about classification at the panel this morning, security kinds of things being classified. The Ware report was classified confidential. In the introduction, it has this interesting statement. Any good research